Moving on to orchestration. Now that we've seen what constitutes an agent, like tools and examples and memory and knowledge base, etc. Those are the same principles that we built Lyzr as well, as you could see here. If you go to an agent, you have a manager agent. If you enable it, you can give other agents as tools, or you can just configure additional tools, any number of tools, and add it to the agent. You have examples here, and you have knowledge base, which is how you convert unstructured data to vector databases. You have data query, which is where you convert a standard agent into a data agent, as you rightly saw. And then you have memory and long-term and short-term memory, etc. So that is how we build Lyzr as well. Very straightforward. Uh, all the aspects of agents are built in, and any custom ones, you could always take the API endpoint and build an additional function to it. We are also launching dev mode shortly. I have, I think, only the screenshot from my founding architect, but let me show you. Yeah, the dev mode is going live shortly, where you can now actually, this is a JSON editor, but you have an direct access to the code as well, where you can also call custom function if required. So just to give you an idea how we are very developer first, but also helping business users build, establishing one single platform. And going back from an orchestration point of view, there are four orchestration techniques, super important. Understanding this is very important because this is where you graduate from an N8N or a Gumloop or a Make.com or a Zapier world to a truly agentic AI automation world. These orchestration techniques makes agents super powerful. And I gave that example yesterday, which I will obviously speak about it again. We had this customer from Canada who built a medium complex system using N8N, and they ended up going all the way up to 52 different nodes. They all are wired. Imagine a 52 node N8N wired with one another. And each node, they had their own tools, they had their own um, memory unit associated, and they all some of the nodes also had certain requests like curl requests and all the other type of third-party integration requests. And it became super complex for them to just handle all of this, which is where when they moved to Lyzr, the same workload, they just had to deal with seven nodes. It was super clean, easier, and in case of Lyzr, the nodes look at, so it doesn't matter just Lyzr, you can do LangGraph as well, very similar. So, but again, your number of nodes really come down a lot. You have router and you're able to have conditional logic if you want, which is a true or false conditional logic. You can have additional agents as well, like a proper DAG. What you're seeing here is router, but if you want directed like a parallel execution happening, you can also establish parallel execution and attach to the agent as well. So these are all nodes, agent nodes. And as you know, in the backend, you just have to select the agent, and you may even select a managerial orchestration here. Now, this is where it gets even more powerful. So while these are all individual nodes, this particular node is actually a research paper builder, and the research paper builder, as you saw earlier, is a managerial agent on its own. So let me bring it up. Yeah, the research paper builder has four more agents within it. So now what happens from an execution point of view, when this gets executed, there are actually four other agents in the backend. And some of these agents can also be managerial orchestration. And that is how the whole, the power of orchestration really comes into picture compared to a workflow platform like N8N. So hence, if you are an agent architect, you need to really understand these orchestration techniques. There are four of them. One is the most easier one, the sequential one, where you have say for example, a data collector, a data processor, and a report generator. There's three agents that are connected one after the other. Then you have the DAG example, the directed acyclic graph. DAG stands for directed acyclic graph, which is where the parallel execution comes in. So what you saw here is a good example of DAG, where There are two agents here, and if you see, this is a router still, but from this agent, we are connecting two other agents. The output of this agent is consumed parallelly by these two agents, completely disassociated from one another. And the output of these two agents are consumed by the final agent along with this. So this agent literally waits for all three agents to complete their job, and then it kind of starts executing. So this is directed acyclic graph where you're able to traverse through the nodes the way you want. So that is the other, that is pretty powerful. Then you have the managerial example, which I think we've seen in number of times. I won't go deeper, but the beauty of managerial orchestration is you have a manager agent and you have two worker agents. But say, for example, the worker B can also be a manager agent in itself, and it can also have additional agents beneath it. So from a like a two-layer system, you can go to a three-layer system. You can even go to a four-layer system or even more. So if you look at these, some of these popular super agents, general purpose super agents like Manus AI, etc. So those are nothing but hierarchical model. They have multiple agents beneath it so that they're reasoning and running into loops to present the data to you. So that is managerial. That's why it's very, again, very powerful and dynamic. And finally, hybrid. Hybrid is again what we saw, where you have combination of DAG and managerial coming together. So these are like the key orchestration techniques that are more, I would say, practical in nature. There are finer nuances to it, which we will see a little later. But these are the things that you should keep in mind from an orchestration point of view.